Hello students, we will see another topic in video mode, that is addressing modes. I have taken this addressing modes from 8085 microprocessor only. So it is actually basic, very basic type of microprocessor 8085. So if you understand this, the similar already we have seen 8051 addressing modes in our regular class, and you can compare this with that. And whereas in 8051 we have seen only four types of addressing modes, so here we have five in 8085. So you can understand what is addressing mode, what is its necessity through this 8085 addressing modes, and the same thing is applicable to microcontrollers also. So first uh, we have these topics already, we have seen all these topics. Now let us complete addressing modes. In next session we will complete instruction set and then timing diagram, and last topic applications in automation systems. So this already we discussed in earlier session in brief. So let me elaborate in detail about applications in automation systems, applications of microcontroller and embedded systems in automation systems. So that is the last topic we will discuss in detail. So addressing modes are different kind of ways the programmer or microprocessor can access the data in the stored data stored in the memory. So it is as similar as the address. So a person is actually located in a house, so that house address should be known to us in order to access him or in order to meet him. So that is only addressing mode. So here a particular person is in particular address, so if we know that address, then only we can find him, otherwise we cannot find him, right? So the person is the memory, the stored data, and that is the stored data is available in that memory location, in that house. So memory location is nothing but house. So 8085 has five addressing modes. The first one is immediate addressing mode, and in a class also I told about immediate addressing mode in 8051 microcontroller, and let us discuss each one in detail, no problem here. Register addressing mode, direct addressing mode, indirect addressing mode, implied addressing mode. So these are the five types of addressing modes. So immediate addressing mode, 8 or 16-bit data can be specified as a part of instruction. So in the instruction itself, I will tell you what is instruction, what are opcodes, what are operands in instruction set. So that is in next session. So before that, just remember the instruction is having the data within itself. So that is the data is specified in the instruction itself. So it can be 8-bit or 16-bit. In 8085, the instructions having I letter. So normally it can be easily identified the mode of addressing mode of any instruction with this letter. So I will show you few instructions examples. So this I letter falls under this category. I indicates immediate addressing mode. So instruction, in the instruction itself, I is I is mentioned. So this I, it is nothing but MVIA, 20H. So this is the instruction. We are going to discuss the instructions. There are 74 instructions in 8085 microprocessor. All 74 instructions we are going to discuss in next session, in instruction set session. So here this is the data, 20 is the data, and H is nothing but hexadecimal number. So this is 20 is a hexadecimal number. So the base is 16. So for decimal number base is 10, for binary number base is 2, for octal number base is 8. So similarly here it is a hexadecimal number. So moves 8-bit data, immediate data 20H into accumulator. So here this 20 is moved or stored in accumulator. So move immediate. So move immediate MVI, MV is move immediate A comma 20H. So this 20 is stored in accumulator. A represents accumulator. So I told you already the importance of accumulator and how accumulator is very effective in programming, 8085 programming. So this is move immediate A comma 20H. So this is the first instruction, and second instruction move immediate M comma 30H. So M, I told you in the last class, in the regular class, that M is nothing but memory pointer. So this memory pointer is actually represents, or it actually points at some memory location address. So in that memory location the data will be stored. So here the memory pointer is having an address. So in that address this 30 is going to stored, and moves 8-bit immediate data 30H into the memory location that is pointed by HL register pair. So that is pointed by HL register pair, and another one is LXI SP. So LXI SP, that is load the register pair. So that is the LXI is nothing but the 16-bit register pair, that is SP. So it is a stack pointer. So stack pointer 2700 address is immediately stored in the stack pointer. So the move 16-bit immediate data 2700H is the address. So 2700 is a hexadecimal number. It is the address into SP register. SP register is nothing but stack pointer. So LXID, so X is nothing but wherever you have this X letter, it means that you are going to deal with the 16-bit data, and it moves 16-bit immediate data 10FF. So that is hexadecimal number. So it is 0 to 9 and A to F. So this is hexadecimal number, and here into DE register pair, and D is stored with 10 and E is stored with FF. So this is the hexadecimal number stored directly in register pair DE. So D is represented here, no E here, only first letter of register pair is represented in the instruction. So this is the first immediate addressing mode. Next is register addressing mode. So the register addressing mode specifies the source operand, destination operand are both to be contained in 8085 registers. So here source operand and destination operand both are registers, and this results is faster execution since it is not necessary to access memory locations for operands. So there is no need to access memory locations, and it accesses the data, or it operates the data directly from register to register. So it is faster. And example, move A comma B, and whatever data is there in B register, that will be moved to A. So moves the contents of register B into accumulator. A is accumulator, and SPHL moves the content of HL register pair into stack pointer. So whatever is there in HL register pair, that will be moved to SP. So that is SPHL. Add C. So add C is the contents of C will be added to the contents of accumulator, and again the result will be stored in accumulator. So that is add C. Direct addressing mode. So direct addressing mode, the direct addressing mode specifies the 16-bit address of the operand within the instruction itself. So 16-bit address is specified within the instruction itself. So the second and third bytes of instruction contain this 16-bit address. So addresses are stored here, or addresses are dealt here. So here 2000, that is 2000 hexadecimal number, it is normally the address. So whatever is there in this address, that will be loaded into accumulator directly. So that is loads 8-bit contents of memory location into accumulator. So 2000H into accumulator. SHLD, so stores HL register pair into two consecutive memory locations, so that is 3000 and 3001. So this is the memory location 3000 is having the higher byte, and the contents of H register into memory location 3001. So that is consecutive memory locations will be stored. So the contents of HL register pair will be stored in 3000 and 3001 memory locations. Indirect addressing mode, indirect way of accessing the data. The memory address where the operand located is specified by the contents of a register pair. So here the address where the operand located is specified by contents of register pair. So you can use the memory pointer, you can use HL register pair, and LDAXB. So loads the accumulator with the contents of memory location pointed by BC register pair. So here B is wherever you see this X letter, it deals with register pairs only, students. Please remember this. And loads the accumulator with the contents of memory location pointed by BC register pair. And move M comma A. So M is nothing but memory pointer. It is HL register pair. Store the contents of accumulator into the memory location pointed by HL register pair. So indirectly we are storing data from one location to another location. So implied addressing mode. So this is the last one, and this implied addressing mode is not there in 8051 microcontroller. The earlier four, all four are present in 8051 microcontroller. So in implied addressing mode, the opcode specifies the address of the operands. So here CMA complements the contents of accumulator. Whatever content is there in accumulator, that will be complemented. So that is the complement operation. RAL, so rotates the contents of accumulator left through carry. So that is RAL instruction. So implied addressing mode. So there is no opcodes, there is no operands. So only we have opcodes. So this is a simple type of addressing mode. So that is the addressing modes. You can refer the microprocessors and embedded systems, Pankaj Gupta, or you can refer Gomkar. Gomkar is the best book. You can refer this, or you can refer Krishnakant, and also I told you to refer Godse, microprocessor by Godse. That is also a very good book. Definitely you can rely on that book. Thank you, students. We stop here. We will meet again to discuss instruction set in video mode itself. Thank you. We stop here, students.